Now this is class 6 of our chapter Integral Transforms. Here we discuss about finite Fourier sine transform, then finite Fourier cosine transform, and one example problem. So finite Fourier sine transform, if f of x is an odd function of x in the interval from minus L to plus L, then we know the Fourier series equation is given by f of x equal to sigma n from 1 to infinity bn sin n pi x by L. That is equation 1. Here bn, the Fourier coefficient, is given by 2 by L. In this case it is 2 by L integral over 0 to L f of x sin n pi x by L dx. So here we are taking only, we have already discussed Fourier series and all. We are taking only this bn. Why? Because this is sine function, so we are taking only that particular term containing bn. Okay, here bn is given by equation 2. Now finite Fourier sine transform for f of x in the interval 0 to L. The above one was from minus L to plus L. And now if the interval that they are given in the question, if it is from 0 to L, then the finite Fourier sine transform is defined as gs of n equal to integral over 0 to L f of x sin n by x by L dx, equation 3. Now from equation 2 we know that bn is equal to 2 by L gsn, because integral 0 to L f of x sin n pi x by L dx is actually gsn, right? So just substituting in that place, so bn will be 2 by L 2 by, this is actually gsn, right? This one is gs of n. So what will be your bn? It will be 2 by L gsn. Okay, that is given here. Therefore equation 1 implies f of x equal to 2 by L sigma over n equal to 1 to infinity gsn. That is, in place of bn we are using 2 by L gsn. Okay, then sin n by x by L is kept as such. So equation 4 actually stands for inverse finite Fourier sine transform. Now similarly, similar steps apply for finite Fourier cosine transform also. Just repeating the steps that we have discussed right now. That is, if f of x equal to is an even function of x in minus L to plus L, then the Fourier series expansion, here in this case, since it is cosine, we take f of x as a0 plus sigma n from 1 to infinity a n cos n by x by L. This we have already discussed in our first class about Fourier series, where a n equal to 2 by L 0 to L f of x cos n by x by L dx, equation 6. Now as did before, finite Fourier cosine transform in the interval 0 to L is given by GCN, because it is cosine, equal to 0 to L f of x cos n by x by L dx. That is equation 7. Now from equation 6 we can write this particular term, this integral term, as GCN. Okay, so replacing, we can get just as before, from equation 6 a n equal to 2 by L GCN, which is equation 8. Now just substitute equation n equal to 0, then we have a0 will be equal to 2 by L GC0. In place of n you are writing 0. Okay, that is equation 9. So altogether substituting, equation 5 will become f of x equal to 2 by L GC0 plus sigma n from 1 to infinity 2 by L GCN cos n by x by L. See here, in the series we have written, that is in equation 5. What was your equation 5? a0, this one. So instead of a0 and an, we are replacing it with the terms. That is, in place of an we write this, and in place of a0 we write this. Then this equation will reduce to this one, and finally to this. Okay, because here 2 by L is just taken outside. In this case here it is taken outside, that is the only difference, and this stands for inverse infinite Fourier cosine transform. So just remember that two formula, that is finite sine Fourier transform and its inverse, then this one finite Fourier cosine transform and its inverse. Now one question based on that equation formula, find Fourier sine and cosine transform. The function is given as x square. So since we have to find the sine Fourier transform first, apply the formula for sine Fourier transform, that is 0 to L f of x sin n pi x by L dx. F of x is given in the question as x square, and the limit is from 0 to 4, right? So in 0 to L is 4. Okay, so that is substituted. Then the rest everything is integration, that is first function into derivative of second, first function into integral of second minus integral of derivative first into integral of second dx, like that. So you are substituting and then proceed to the integration. I have worked out a few steps, so please go through those steps, and either you can work out in your own way. This is the way that I have worked out, so you follow your steps first, okay, because this is the term that you have to integrate. So just write it down and then integrate it yourself in your way, and finally check whether you are getting the answer as 128 by n square pi square cos n pi. The rest everything is integration. I have worked out the steps that I have followed. If this is difficult, you can work it out in your own way, but just check the answer, and if you are not getting the answer, you can follow my steps. Okay, and few problems also I will upload as a PDF for your reference. Okay, thank you.